The diagram window provides a nice way to control your EES program. We've seen how you can use the inputs on the diagram window to set variables that are then used in your program, but there's even more sophisticated ways of controlling your program that are available, and one of these is a string list that you then map to a set of equations. So let's do a quick example showing how this works, and then we'll go back to the EES program that we were working on in the previous video, and we'll use this idea to make it more professional. So here's an EES program. It's a very simple one. It just calculates the area and the volume of a square extrusion that has side length W and length L. So I'll go ahead and build a quick GUI in the diagram window for this. So I'm going to have I guess two inputs, right? The inputs are W and L, and I'm going to have two outputs. The outputs are the area and the volume of the extrusion, and we'll add a calculate button and get rid of the corresponding equations in the equations window, and I'm done. So maybe I want to make this work for other extrusions, like one that has a circular cross section. So if I need this to work for a circular cross section, then the parameter W might be the diameter, and what I need to do is change the equation that calculates the area from W squared to pi W squared over 4. I'd also need an easy way for the user to specify which extrusion he or she is interested in, square or circular. And one good way of doing all of this is to map a string list to a set of commands. So to do this, what I'm going to do is select add text from the toolbar here, and then I'm going to specify that I want to add an input variable. And this input variable is going to be a new string variable. So let's call this string variable type $, and we'll use a string list as we've done before to constrain the selection to either square or circle. So at this point now I have a new variable, a string variable type $, and the user can either set it to square or circle. All this we've done before. Now the new twist on this is that I can now add a set of equations that go with either of these selections. So if I go back and I edit the string list, and do that by putting the diagram window into development mode, I'll double click on this drop down box and then select edit the string list. What I want to do then is add 2 forward slashes after each selection, and what follows the forward slashes is going to be then a set of equations that go along with these selections. So here for square, I'm going to want to calculate the cross-sectional area of a square, so I will add A equals W squared, and for circle I'm going to want to calculate area differently, so I'll add A equals pi W squared over 4. Now because I'm adding these equations in the diagram window, I need to get rid of the equation for area in the equations window. So I'll go back and do that, and at this point if I go back to the diagram window, put it in application mode, you can see I can now switch between the two types of extrusions, and when I hit the calculate button it will determine the area and volume for either a square or a circular extrusion. Maybe we want to clarify what the extrusion cross section looks like, and also what the parameter W refers to. And so to do this, we will draw a diagram here. So we'll draw a square and we'll draw a circle, and that's pretty easy using the palette. And then I'm going to indicate what W is right on this picture here. What would be really cool is if the circle showed up and the square went away if I selected circle from the drop down menu here, and the other way if I selected square. And this is pretty easy actually, and we do this by naming these two graphic objects. So we've done this before. If I go and open up the square, I'm gonna name it square, and then because I've named it I can control any of these attributes. Notice that there's this attribute hide. If I set hide equal to true, then it'll be shown. If I set hide equal to false, then it won't be shown. Same thing for the circle. I'll name that one circle. Now I can control whether these images, these graphics objects, appear or don't. And I'll go back to my string list and I'll edit that string list. I'm going to add a couple more commands, so I can add as many as I want here with semicolons. So square dot hide equals false keeps the square, and circle.hide equals true hides the circle. And then if I'm selecting the circle, I'd like the opposite thing to happen. So square.hide equals true, and circle.hide equals false. And yeah, now I have a set of equations that are being executed based on which of these selections I make. And you know, if you have more equations than can conveniently be fit on a line, you can always use a $include directive to add an entire text file containing as many equations as you want to go with each selection. Alright, now if I go back and put the diagram window into application mode and I hit calculate, you can see that the area and the volume are updated and the picture is updated as well. And this isn't really what I want. What I'd really like is to have the picture update immediately when I select the cross section from the drop down menu, and that's also possible. So if you go back to the string list and edit it again, you can see that one of the selections underneath it is execute commands when the selected input is changed, which just basically means exactly that. When somebody changes the selection of the drop down menu, you immediately execute those commands. So let's go ahead and check that and put it back into application mode, and now you can see that it operates sort of exactly the way that I'd expect it to. Alright, so now that we understand how to map string list selections to a set of equations, let's go back to that EES program that we developed in our previous video, which was plots in the diagram window. So this program, if you remember, it simulates a turbine, and then once the turbine simulation is complete, it puts the states, the input and output states, on either a TS or a TV diagram, and that diagram is shown in the diagram window. So because we didn't know how to map string lists when we made that video, the user selected the TS or the TV diagram in this EES program just by setting the value of the variable we call tab. And we could set it either to 1 for plot tab 1, which was the TS diagram, or for 2 for plot tab 2, which was the TV diagram. And because the plot object itself was named plot, then all we had to do was assign plot tab number to the value of tab, either 1 or 2, and we would then be changing what was shown in the diagram window. So there's an easier way, obviously, at this point, and that way is to get rid of this variable tab, and we'll get rid of the associated command in the equations window that assigns plot tab number, and instead we're just going to add a string list. So go ahead and do that. So the string is going to be plot $, and the values that will allow the user to select are either TS or TV. And then the command that is mapped to these selections will just be setting that plot tab number to either 1 if it's TS or 2 if it's TV. And I think we probably want these commands to be executed automatically, so that when somebody changes the selection, immediately the diagram will update. So let's go ahead and do that, and we'll put this back into application mode, and you can see that the result is a much more professional looking GUI for my turbine simulation now.